Hi, welcome to the Euclidean Geometry 101 course. Last time we introduced polygons. This time we will start looking at the simplest class of polygons, namely triangles. Arguably, they are the most interesting class of polygons. The chapter of triangles will span several videos. This first video will introduce the triangles and the terminology surrounding them. We know that a triangle is a polygon or a closed broken line with three straight line segments. The three straight line segments are delimited by 3 points, and we can see that the triangle not only has 3 sides but also 3 angles. Its construction is simple, namely each triple of points that is not collinear forms a uniquely defined triangle. A, B and C are the vertices of the triangle. AB, BC and CA are the edges or the sides of the triangle. A side and an angle are adjacent if the vertex lies on the side, for instance AC and angle A. A side and an angle are opposite if the vertex does not lie on the side, for instance AC and angle B. It is very useful to classify the different kinds of triangles. A triangle is called isosceles if 2 sides are equal. The 2 equal sides are called its legs. The vertex between those sides is called the top, and the third side is called the base of the triangle. The angles are named top angle and base angles. A triangle is called equilateral if the 3 sides are equal. A triangle is called a right triangle or a right angle triangle if an angle is equal to a right angle. The opposite side from the right angle is called the hypotenuse. A triangle is called scalene if the 3 angles are all different from each other. An acute triangle is a triangle with 3 acute angles. An obtuse triangle is a triangle with 1 obtuse angle. Acute and obtuse triangles are 2 different types of oblique triangles. This in contrast to right triangles. If we consider a vertex in a triangle and its opposite side, we can define a number of special lines in the triangle that have a relationship with those two. We will now define some of these special lines. Let's take the midpoint of the opposite side and then connect the vertex with that midpoint. The obtained line segment is called a median in the triangle. It is AM in the figure. If you have difficulty remembering that name, associate the midpoint with it. An angle bisector in a triangle is the line segment that starts in a vertex of the triangle, divides the angle determined by that vertex in 2 halves, and is delimited by the opposite side. It is AD in the example. An altitude in a triangle is the line segment starting from a vertex of the triangle and perpendicular on the opposite side. It is AH in the figure. The point on the opposite side is called the foot of the altitude. Remark that the foot of an altitude does not necessarily lay on the opposite line segment. It can also be located on the extended line segment. If we again consider the midpoint of a side of a triangle, we can also construct the perpendicular bisector of that line segment. A perpendicular bisector of a side in a triangle is a line that stands perpendicular on that side in the middle of that side. For instance, MI. A fifth and lesser known special line in the triangle is a semedian. We first construct the angle bisector and median of a vertex. Then we reflect the median around the angle bisector. The line segment that we get, starting of course in the vertex and delimited to the opposite side, is called a symmedian in the triangle. In the figure, this is AE. In the case of median, altitude and angle bisector, we define these as line segments. But the same name is also used when we take the extended line that coincides with them. All the lines in triangles that start at a vertex and intersect the opposite side are called cevians. The name comes from the Italian mathematician Giovanni Ceva. Medians, angle bisectors, altitudes, etc. are all special cases of cevians. If you like this series, consider subscribing to my channel.